So what is a surd? A surd simply means the irrational root of a rational number. We express it with this sign. What do we mean? When you see this sign, and this is 4, for example, and you have been told what is the square root of 4. The square root of 4 is 2. When we say the square root of 4 is 2, what do we mean? We mean that when 2 multiplies itself, it gives us 4. On the other hand, let's say we are given 9, and you have been told to find the square root of 9. Let me just draw this line like this. The square root of 9 is 3. What it means is that 3 times 3 is 9. You understand? So when you just see this sign like this, there is a hidden 2 here. We'll go into that in detail in later classes. There's a hidden 2 here. But if you see only this sign and you did not see any number here, just assume that what is here is 2, meaning that you are looking for the square root. But if you see another number, let me say you have something like 3 here, that's the cube root. Cube root means, let me say for example, if you have been told to find the cube root of 27, cube root of 27 is obviously 3. What does it mean? It means that 3 times 3 times 3 will give you 27. So if you look at this place, I said there is a hidden 2 here. You see that it's 2 times, but here now it's 3 times. That's why you see that it's 3 here. On the other way, you can also have something like, you have 4 here, 4th root, and you'll be told what is the 4th root of 16. The 4th root of 16 is 2, which means 2 times 2 times 2 times 2. That's 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. And so on. We also have the 5th root, 6th root, but whenever we are dealing with surd, most times we are dealing with just this sign alone. And whenever you see this sign alone, it means you are dealing with square root. Now, without using calculator, how do you find the square root of a number? Without using calculator, this is how you find the square root of a number. These are, as I said, introductory class before I delve into surd and the calculations. For example, we are given 16, and you are being told to find the square root of 16. The normal way for solving this is like this. You use the normal factorization method, where you say this is 16. What's the smallest number? Look for the smallest number that can divide 16. The smallest number that can divide 16 is 2. By so doing, you get 8. What's the smallest number? It's still 2. By so doing again, you get 4. What's the smallest number? 2. By so doing, you get 2. What's the smallest number? 2. By so doing, you get 1. So these are the whole factors of 16. Since because you are dealing with square root, you take it 2, 2. This will just be 2, and this will just be 2. So the total square root of 16 is 2 times 2, which is 4. So square root of 16 is equal to 4. This is how you solve for square root without using the calculator. Let's do another example. Let's say you want to solve for the square root of, let me look for a bigger number, square root of let's say square root of which number will I use? It's very big. 100. Yeah, 100. Let's use 100. Square root of 100. Find square root of 100. Use the same method. Just put it here. What's the smallest number that can divide through? It's still 2. If you go divide by 2, you get 50. What's the smallest number again? 2. If you divide, you get 25. Now, what's the smallest number that can divide 25? 5. You get 5. What's the next smallest number? 5. You get 1. So these are the factors of 100. So you just take it 2, 2. Here is 2. Here is 5. So 2 times 5 will give you 10. So the square root of 100 is equal to 10. So this is how you can solve for square root of a number without using the calculator. This is how you can solve the square root of a number without using the calculator. Same thing applies, though not to confuse in this class. Same thing applies to when you're looking for the cube root. You take it 3. But these ones are able to go through because these are perfect squares. There's a numbers we call perfect square. Numbers we call perfect square, numbers that when you find their square root, you get a whole number, or at least you get a rational number, because you can get something like 1.5. It shouldn't be a recurring number. Surd comes in when you have a number that cannot be fully give you a rational number when you look for the square root. But before I move in, let's do another example for surd of a number. The next number I want to pick is, let me say I pick 81. Let me just draw this line here. Let me pick 81. Let's say find square root of 81. Now you have something like factorize it. 81. What's the smallest number that can go divide through 81? It's 3. When 3 divide 81, you get 3 go here. You have 2. You carry 2, put it here, 21, which is 7. The smallest number that can go through 27 is still 3. 3 go here. You have 9. The smallest number that can go again is still 3. You have 3. 3. You have 1. So you take it 2. Here is 3. Here is 3. So it's 3 times 3 is 9. Therefore, the square root of 81 is equal to 9. So this example we just did will help you a lot in knowing how to factorize surds. You understand? We have perfect square number. Perfect square number are numbers that gives a rational number as their root, which I've said earlier. So now let's go through the textbook and see the examples that they give. Now this is the textbook, and these are the examples. We have square root of 45, or you can use the word root 45, root 162. This is now they are using what we call this invariable here. You understand? So we can still work with this, and this is that. Now we are being told to simplify. This is where surd comes in, because when you are dealing with surd, you are dealing more with. So the examples you can see here, none of them are perfect square. By mere looking at it, you will know that they're not perfect square. If you are used to perfect square are numbers like 2 times 2, which is 4, 3 times 3, which is 9, 4 is 16, 5 is 25, and so on. So none of them fit in here. So now we are being told to simplify. What do we mean by simplification? By simplification, they are trying to tell us to reduce all these to make sure that what is inside the root is the smallest number that can be there, while the rest comes outside the root. So this is where the former exercise we did on getting the square root of a number comes into play. You understand? This is how they are solving it. Look at what they are doing. They will just tell you 9 times 5 is 45, because they already know that the perfect square inside 45 is 9. So for that reason, they find the square root of 9. So, but I will not use this method. I will simplify it further in my own example, so you can get the real calculation. So these are the examples given. Now we have square root of 45. So when you are given this kind of example, the first thing you are going to do is to simplify this 45 further. Remember the examples, remember the exercise we performed there. So what you will do is this is equal to, simplify everything that is inside there. 45 is the same thing as 3 divided by 45, the same thing as 3 times 3 times 5, which is the same thing as square root of 9 times 5. Remember, in our example, you take, for you to get a square root, you take it 2. So this 2 already, if we are to jump step, is already means that this which means that this 3 is already a perfect square, which you can get the square root, and then you have the 5 remaining. But from there now we have 9 times 5. You understand? This is the same thing as, remember what we did here. When we check, we find out that when the two numbers are inside the root, is the same thing as when you say the square root of this multiplied by the square root of that. So we'll now apply that law here. This is the same thing as square root of 9 times square root of 5. So your final answer, then the square root of 9 is what? 3. It will be the same thing as 3 times square root of 5. But since we can't get the square root of 5, it's now an irrational number, so you still leave it in this format. So the final answer is 3 root 5, because this multiplication is the same thing as leaving it in this form. So you see what makes it a surd. Surd is now you are expressing this number that you cannot get the perfect square root in a form that is simplified and still have this sign on it. If you look at our definition of a surd here. So this is the first example. Let's check for the second one. This is the same thing as square root of 3 times 3 times 3 times 3 times 2. I know some of you be wondering, how did I know that this is it? That it's just very simple. Just put this 62, just put it in this format. Just put it in this format and you start dividing it all through. You can say this is 3. When 3 divide, you have 5. Take 1 here, you have 6. 3. When 3 divide, you have 1. You take 3 divide here, we have 5. Take 1 here, you have 4, not 6. When 3 divide, you have 5, you have 1. You take 1, you have 8. 3 divide, you have 6. 3 divide, you have 2. 2 divide, you have 1. So this whole factor is what I put inside this place. The same thing applies to this one. So now, as you can see, this 3 multiplied by 3 multiplied by 3 is the same thing as square root of 3 times 3 times 3 times 3. As you can see, this is a perfect square from the example we did here. This is 81. So it's written as 81 times 2. So if you simplify further using the rule, the product rule that we used earlier, you can say square root of 81 times square root of 2. Then you now have square root of 81 is 9. So I think I missed it. Square root of 81 is equal to 9. Why square root of 2? You can't divide it, so it still remains in that form. So you now have 9 times square root of 2. So the final answer is 9 root 2. This is the simplified version. Hope you are making sense. Coming to this one we don't have much to do, is just alphabet. So we still use the same method we use in numbers to solve it. X square, we can just say square root of x square times square root of y. Now for alphabets like this, once there is square here, all you need to do is just divide it by 2. That's the square root. You understand? Because it's x square, just divide this power, the power of that alphabet, by 2. So you have something like square root of x square will give you x, since 2 divided by 2 is 1. So this is 1, so you don't need to put it. That's how it is. Times square root of y. So it is x root y. This is the final answer. Then we come here. Here now we are having another number that is outside already. So it will be 3 square root of 5 times 5 times 2. And 5 times 5 is already 25. How did I get this 5 times 5? The same method I used here. So you have 3 square root of 25 times 2. So it will be 3 times square root of 25 times square root of 2. So it will be 3 times square root of 25 already is 5. We already know is a perfect square, times square root of 2. We can't find the perfect square for this, so we still leave it in this form. So 3 times 5 is 15 times square root of 2. So the final answer is 15 root 2. So this is the simplification for the whole surd.